Okay, we're still looking at graphs of linear equations. We're going to talk about slopes and applications. So we're going to be given coordinates of 2 points on a line, and we're going to find the slope of that line if it exists. We're going to find the slope of a line from an equation, and then we're going to find the slope or the rate of change in an applied problem involving slope. Again, that's the word terms. So we've looked at two forms of linear equations in the previous section, ax plus by equals c, and y equals mx plus b. We know that the y-intercept of a line is at 0b. So what about the constant m? Does it give certain information about the line? Look at these and see if you can tell anything's different about the slants. I just want you to look at them for a second. This is where we would have some conversation about this in class. What do you notice about the first one right here? This one here. We have 2/3 x minus 1. It did cross the y-axis at -1. And if we look at the slope, we might could come up with a couple of things that we haven't talked about, but you should have learned at some point. But also, if you notice this 2/3, it's positive, and it looks like our slope is positive. Again, all of these crossed at -1, but if you look at the different slopes, this is a reciprocal of this one, and it changed signs between this one here and this one. This is a negative slope, has a negative in front of it, where this one was positive. Okay, it says graph the line containing the points. So we can graph the lines, or we can look at where the points are. If you graph the points first, so this would be 4, -1, and this one is -4, 5. So it says it's rise over run. So if I go 1, 2, 3, 4, 5, 6, I went down 6, so that would be -6. And then let's see how far we go over from that point. 1, 2, 3, 4, 5, 6, 7, 8. I went to the right 8 times, so that's +8. So our slope should be -6 over 8. If you wanted to do it mathematically instead of graphing it, you're going to say x1, y1, x2, y2. So the first thing we're going to say is we're going to say -1 minus 5. Then we're going to put it over 4 minus a -4. So it gives me -6 over +8. And look at there, it worked out. Now the other thing that you do is you need to simplify this. So this actually becomes -3 over 4. The slope of a line tells how it slants. A positive slope, it slants up. I think of it this way. If I'm driving along and I'm reading left to right, I know driving and reading, it didn't make sense. But if I'm looking at a graph and I'm going left to right and I keep going and I hit that slope and I go up, that's positive. We'll just put a plus sign. If I'm driving along or looking at this slope and I hit the slope and I continue downward, that would be negative. So that's how you can tell if a slope is positive. It is possible to find the slope of a line from its equation because you're just really looking for what m is. M represents slope. So if we look at this first one, our slope on this one is -4. On B, it's +2/3. On C, it's understood there's a 1, so there's a 1 there. And then on D, it's going to be -0.25 is our slope. Alright, if you notice, this one is written as AX plus BY equals 15. So we have 3x, or sorry, equals C. we need to solve it into y equals mx plus b. So we have 3x plus 5y equals 15. I'm going to subtract 3x from both sides. So 5y equals negative 3x plus 15. Divide by a positive 5 under each one. So y equals negative 3/5 x plus 3. Our slope is negative 3/5. This one said to find the slope of y equals 3. Remember, what did I tell you? Y equals 3. If it goes through the y-axis, it has horizontal. So when it has a horizontal, it has a slope of 0 automatically. Has a slope of 0 because it's a horizontal line. Now when you have x equals 2, it goes through the x-axis like this, creates a vertical line. Vertical lines have a slope that's called undefined. It's not 0, it's not null, it's just undefined. You can't really tell what it is. So slope 0 and slope not defined, the slope of a horizontal line is 0. The slope of a vertical line is not defined or undefined. All right, when you're dealing with applications and rates of change, some applications use slope to measure the steepness. For example, numbers like 2%, 3%, 6% are often used to represent the grade of a road. Truck drivers, if you know how that goes, it's that steepness. That is, a 3% grade means that for every horizontal distance of 100 feet, the road rises or drops 3 feet. Okay, so when you're looking at the treadmill, we're looking at the distance from the time that it starts to elevate, or from the floor till the time it starts to elevate, the final elevation. It begins at slope right here. So we want to know what its grade is. So if it's 5.5 feet and then it's 0.42, this is your rise over your run. Remember, you could think of this as your y-axis, and this is your x-axis. So rise over run. You don't have to worry about that. They multiplied it to get rid of the decimals. But if you were to have divided that out, you would have gotten 0.076. You move your decimal place 2 places because it's always expressed in percent, and you get 7.6%. Take your time on these. This ends this lesson.